Hope everybody's had a chance to get settled in. We're going to start with our next panel. This panel is on speed management, and we have three presenters. Our first presenter is live, and followed by somebody presenting virtually, and then we're going to have finally a recording from our third presenter. So we're going to start off with our first presenter, and I'll just read his bio. His name is Abdul Razak Alozi. He's a third-year PhD candidate from the Department of Civil Engineering at McMaster University. He joined the team of Dr. Mohammed Hussein back in 2020 and has been focusing on safety impacts of autonomous vehicles on active road users in urban traffic situations. He has experience in several key transportation fields, including traffic modeling, machine learning applications, and intelligent transportation systems.
Thank you for that introduction. What I'm about to present, I think, fits in well with what we heard in this morning's keynote. We've heard a lot about speed limits and how they might have a significant impact on safety. And I think in this study, I'm advocating for this kind of change and showing the impacts both on safety and also trying to alleviate the concerns that come with it. For example, when reducing the speed limits, people often are afraid of worse traffic operation, more delays, or more travel times. So in terms of background, as you're all aware, in urban traffic specifically, traffic engineers often resort to multiple methods to try to improve safety. Some of these methods include road geometry, as well as traffic control devices, and of course, posted speed limits. Now, posted speed limits can be studied, and we can actually look at the impact of posted speed limits and how they, or changing the posted speed limits using a multitude of ways, including, for example, before and after studies, like what was explained earlier today. But also when there's lack of data or limited collision data, we can look for alternatives. For example, one of these alternatives could be to look at the traffic conflicts as a surrogate for traffic collisions. And this can be a quite a reliable approach, as I will be explaining in this study. So first of all, this is not new. In the literature, the relationship between conflicts and collisions has been well established. And in some cases, simulation-based approaches have also been shown to provide reliable performance in quantifying this impact. And in terms of previous work, what I'm about to explain here is basically there are some studies that have been focusing on increasing the speed limits or reducing the speed limits. And these studies, for example, studies that focus on increasing the speed limits often look at highways and arterials. And they, without going into much detail, they often find a significant increase in the number of collisions, or additional collisions due to the increased posted speed limit. This is, of course, the opposite when you look at reducing the speed limits. And this can be both in terms of frequency and also severity of these collisions. So in terms of the objectives, the specific objectives of what I'm trying to do here, I'm trying to evaluate the impacts of reducing the posted speed limits on signalized intersections specifically, and also to examine the the protected left turns, which are can be a useful tool to mitigate pedestrian safety impacts, or try to improve pedestrian safety specifically. So the data I'm working with comes from the city of Bellevue in the US, and it has basically 6 signalized intersections. And you can see here, for example, matching what was mentioned in the keynote earlier this morning, the speed limits, the existing speed limits are 30 and 35 miles per hour, or what equates to in the vicinity of 48 kilometers per hour to 56. So pushing these down closer to the 30 kilometer per hour range would be a potentially a positive improvement. So this is what I'm trying to quantify here. Without going into much detail about the data, I'll just show you what kinds of data that I had access to. And these include, on top of the traffic data, the hourly traffic data, the conflicts. And these conflicts are essentially near misses. And they are quantified with a conflict indicator called the post-encroachment time, or PET. This is basically the time difference between when the pedestrian crosses and when the car reaches the same area that the pedestrian crossed. And also to validate the numbers or the models that I'm creating here, the collision data history from for 5 years is also available. So in terms of methodology, and this is what I'm doing here is a simulation-based approach. Without looking into each detail, basically the gist of it is that the inputs I had were the traffic operation and number of conflicts, and I used these for calibration as well, which is what I will be explaining a bit more in the next slide. But also to emphasize the how the reduced speed limit will impact operating speed. It's not like people will not just follow the posted speed limit, but studies have shown that reducing the posted speed limit will impact the operating speed at a specific range, which I'm using here. So this is the important part of the simulation approach, calibration basically. And I'm following a 2-step calibration process, which is first to calibrate the operational parameters, which include the delay times, the arrival types, as well as the speed distribution, the operating speed distribution. And then to try to match the conflicts that I'm seeing in the field in the simulation model, which can be done using the following thresholds and minimum gap times. And as you can see, overall, the models show a good fit with a low mean absolute error. So they match reliably the field conditions. Now, in terms of scenarios considered, and this is where I'm trying to address both sides. Both safety and mobility parameters have been collected just to see what the impacts would be on all or both these sides. And I'm focusing mainly on 4 scenarios. So the existing speed limit, which I showed in the data slide, and also 5 kilometer, 10 kilometer, and 15 kilometer speed reduction, as well as, of course, the protected left turns. And finally, to end up with a concrete, solid statement, I'm also doing collision prediction. So because conflicts are near misses, they're not collisions, they can provide us with a reliable estimate of the predicted collisions using something called the extreme value theory. And this, in fact, has been shown to produce reliable estimates. And I've tested it on the data I have because I have collision data. I tested the model on pedestrian collisions specifically. And as you can see, I have 6 locations here. and the model has been shown to somewhat match the field collisions, except for a bit of underestimation. So it underestimates the collisions to a certain degree. So the results basically showed that in terms of total conflicts, reducing the posted speed limit by 5 kilometers per hour can reduce the conflicts significantly. But also, more importantly, if you look at the distribution at the right-hand side, the red curve is the existing speed limit. And you can see that because the PAT is a proximity measure, as it goes down, the severity increases. So basically having a lower peak at the lower end of the spectrum means that the severity of these conflicts is also reduced. Now, because we have a collision prediction model, getting the results of collisions out of these models can show also an important outcome. So if you look at the predicted collisions row, you can see that at the existing speed limit, we have a 29 overall predicted collisions. And just to match the actual collisions data, we had 32 collisions in the actual data. So again, it's a slight underestimation. But you can see that with the reduced speed limits, we have a significant reduction going all the way up to 25.9 collisions in the study period. Now, as I said, I also looked at protected left turns, and I tried to go further into the specific conflict types, and I'll show these in the next slide. But overall, protected left turns did not have a significant impact in terms of reducing collisions. The reduction was marginal, but and also the severity was not significantly impacted. But looking at specific conflict types, and this is what protected left turns are often there to do, you can see that vehicle pedestrian conflicts specifically experienced a higher reduction, as well as left turn opposing conflicts, which were reduced by up to 11.6%. So compared to overall protected left turns, the impact was marginal, but specific conflict types were much more impacted. Now, going into the mobility side of things, because I said we've already seen that these changes in posted speed limit can have a much improved performance and safety, we can see that in terms of operation, of course, the average delays increased as we reduce the speed limit, as well as the travel times. But these increases are much less than what you'd expect or what people would be afraid of. So the increases in average delays were not more than 5%. And in terms of travel time, it was even less than that. So I'll conclude with a few statements, and I'll not repeat what the results have shown, but I'll just emphasize that in terms of safety and the safety impacts of reducing speed limits, and this can be different in urban roads than highways, you can see that the reduction is significant. And without even looking at the predicted collisions, the conflicts themselves were mitigating up to 3,000, or sorry, even more than 3,000 conflicts by just reducing the posted speed limit by 5 kilometers per hour. And the severity of these conflicts is reduced. And on top of that, the adverse impacts on mobility are not that severe. So it's always a trade-off, but I believe that this can show or basically inform possible decisions that it's not as bad as one might think. And of course, the safety impacts are much more significant. Thank you for listening.
We'll have an opportunity for questions at the end of this session. So we'll go to our next speaker. Our next speaker is Rahim Dilgir. He's presenting virtually. You may have been introduced to him yesterday as he was speaking yesterday. I'll welcoming the conference. I'm just going to read his bio for you. So Raheem Dilgir is a level 2 road safety professional with 27 years of experience in Canada and internationally. Over the past 10 years, Raheem has operated TransSafe Consulting Limited, to which he assists road agencies across Canada in development, delivery, and evaluation of road safety plans and projects. Raheem is currently the co-chair of the TAC Vision Zero and Safe System Committee. So Raheem's going to be speaking about speed management and safety at rural and urban transitions. Please welcome him.
Thank you, Jeff. Just want to confirm two things. You can see the full screen, or do you see the one with the notes?
The full screen.
Great. And can you hear me okay?
Yep.
Great. Okay, thanks for the introduction and welcome everyone. I'm joining you from Vancouver, the unceded territories of the Squamish, Musqueam, and Tsleil-Waututh peoples. I would much rather be with you there. Unfortunately, for personal reasons, I was unable to. But I also just wanted to acknowledge, if you'll permit me a moment, just how challenging it is to put on a hybrid conference. And I think this session is a good example that shows that three different types of presentations: a live presentation in person, a live virtually, and then a recorded presentation. And the team is pulling it off. And I just wanted us to just take a moment to recognize the hard work and effort of the staff and volunteers for the conference. Thanks, everyone. Okay, so I'm going to be speaking to you about a topic which I thought was good for this session on speed management. We often talk about speed management in the context of urban areas, and I know there was, I believe there was just a session before this one on rural road safety, which is a rural speed management, which is important because most fatalities in Canada still occur in rural areas. But I thought one thing we don't talk enough about is the transition between urban and rural areas. And just from the work that I've done over the years, when we screen the road networks, it often is towards the outer edges of a municipality where there's a lot of collisions concentrated. And it's not surprising. It's simply because it is a transition area where motorists are still adjusting to a new condition. So I thought I would share just a few examples of what are some of the issues in transition areas, and just backing up, look at the various contexts. What is it that characterizes rural and urban and other types of areas, and then what are some of the suggested treatments that we could apply to help manage safety and speed in those types of areas. So starting with the land use contexts. This, I think you'll agree, is a good representation of more urban context. So that's one end of the spectrum. Here you have a urban arterial road, and then on the right you have more of like a city core where there's a lot of activity, including transit, high rises, high access density, etc. And then sort of the other end of the spectrum is shown on the right here, a country road, which is mostly natural surroundings, in this case no pavement markings. Then on the bottom right, you have more of a rural freeway with a depressed median, a cable barrier, again, natural surroundings. Then on the left, you have one that's a bit more of in a transition area. So you see it's still a highway. It's the Highway 2 in Alberta. But this is going through one of the many small towns that highways do in Alberta. And so you can see the hints of some local development there, and it's these types of areas that sometimes have quite a mixture in the way that motorists perceive and use the environment and manage their speeds. Now, I'm not going to talk about these, but you see just the full range of other types of areas. You have suburban, campus, more industrial lands like port lands. And so my message here is just to really look at the context when you're looking at ways of speed management. There's not just one approach, and it has to be a context sensitive approach. But looking more at the sort of the typical urban and rural, I'm just going to describe some of the operational characteristics, the differences, before we get into the issues and treatments. So if you kind of think of it as a continuum from rural to urban and look at a number of operational factors, you'll see where it differs in rural and urban areas. So when we talk about vehicle speed, typically we're talking about higher speeds in rural areas. If you have an urban freeway through a city, well then yes, you'll have it's higher speed in an urban area, but this is again the more typical situation that you encounter. Again, typically vehicle volumes are lower in rural areas, higher in urban areas. The number of conflict points and accesses is higher in urban areas, lower in rural areas. And the amount of pedestrian and cycling activity is higher in urban areas and lower in rural areas. Having said that, there's a lot more long distance cycling and people just using active modes these days. So a lot of it is happening in the rural areas as well, but much more so in urban areas. So some of the issues that impact speeds and safety in these transition areas is what I will attempt to cover now. So number one, jurisdictional differences. Some of the examples that I'll be giving today is from a study that I completed near the Alberta-Saskatchewan border, just outside the city of Lloydminster. This was not only different jurisdictions in terms of the provinces, some of the city being in one province and the rest of it in another, but also when exiting from the city, there's another transition into the more highway environment on the Saskatchewan side. So at jurisdictional boundaries, what you often see are changes just because standards are different between provinces. Sometimes that is well thought out and there is good transition provided, but in other cases, you do see a bit of a difference in the type of infrastructure, maybe the type of median that's being used, etc. What you typically see in terms of the road geometry is if you look at the other two graphics here, is a rural cross section shown in the middle, where you have the vehicle lanes in the middle, and then a shoulder, and then a clear zone, which is where you're not supposed to have any rigid objects that could become hazards, and then you have the more natural surroundings on the outside. Then in a more urban situation, you'll have more defined space for different modes, including, in this case, transit and cyclists, pedestrians, etc., sometimes separated by curbs or barriers. So that's one thing that you'll see. Another thing is just a lot of signs at jurisdictional boundaries that add to the workload. I think I'm going to be talking about that shortly. But something else that's quite important or quite significant that you see in transition areas is the high variance in speeds. That means that some vehicles are going much higher, much faster than others. And this is important because there is a correlation with safety performance. So from this graphic on the left, you can see that where you have a smaller deviation from the average speed, you have a lower crash involvement rate. And I think the same would apply to injuries and fatalities. So, and you see all kinds of behavior occurring, such as lane changes, tailgating, and those other types of behaviors that often lead to collisions. I alluded to this. There is also a change in the workload when you're entering or exiting a municipality. And so in this case, the outside of Lloydminster, I just wanted to point out a couple of key things here. You have right here, I don't know if you can see my mouse where I'm pointing, but anyway, it's at the very top left of the left diagram. You have in yellow, the vertical line in yellow is a railway overpass. And as soon as drivers exit eastbound is to the right, and pass under that railway overpass, that overpass sort of acts as a natural gateway. And when people pass that, they typically think that they're home free. and they can increase to whatever speed is comfortable to them or what the eventual speed limit is. And then they, then what happens? Then they encounter a curve, a relatively sharp curve, an access nearby that curve, an at-grade railway crossing, which is well used, a major intersection to another highway, and then another access to a major industrial facility here. So they're not out of the woods, and it's interesting to recognize what are the features that communicate or provide cues to the motorist that they should now speed up or slow down. And we found that overhead, that railway crossing was one of those. So even though they were technically out of the city limits when they pass the overpass, drivers still do face a significant amount of workload. But in the more common situation, when you're going from a rural to a more urban area, the workload increases in that direction. There's a lot of signs upon an entry to a city that refer to various things about that city, tourist oriented, some laws, other things. But you see that in both directions as well. In this case, because you're at the provincial boundary. So on the right, you see in addition to the speed limit sign, which eventually it goes up to 110 prior to this major intersection, which was an issue. You have a number of other signs which have nothing to do with the traffic control, but are provided that may act as a distraction as you're approaching a key intersection. The next issue I want to mention is gap assessment. This was referred to in the previous presentation, that where you have, especially with the high variance in speeds, it's then more difficult if you do have a conflict point like an intersection to judge the speeds of oncoming vehicles. And of course, the size of a gap is directly related to speeds. So it's quite common to misjudge the speed and the gap of traffic in an area, in a transition area where speeds are variable. So those are some of the key issues. There's probably more, but those are the ones I've chosen to concentrate on for today. And in terms of treatments that could be used to address some of those issues, the most traditional and perhaps obvious one is a transition speed zone. So as I mentioned, the speed limit goes from 110 at the east end of the Saskatchewan side, and then it goes to 60. Okay, what we suggested as part of this review is to insert an 80 zone, an 80 kilometer an hour zone that would span a couple of kilometers to provide that area for transition and adjustment. In addition, we recommended a 60 ahead zone, which is yet another transition and a reminder just before the lower speed zone that at the entry to a city, to really emphasize that. So that's sort of the first approach, is a transition speed zone. Another approach is transitional markings. This is an example of a measure that can be used very effectively in transition areas. In what we're showing here are called optical speed bars. And what they are transverse markings at the edge of a travel lane, which are spaced as you proceed along the road. They're spaced closer and closer together. And what that does is it creates almost an illusion to the driver that the lane is narrowing, and therefore that tends to lead to a speed reduction. Okay, even if it's happening at the subconscious level, it works. That's the way that it works. So that's probably the best example of a pavement marking treatment that could contribute to lower speeds in a transition area. The third treatment I'd like to talk about is median treatment. Drivers take cues, again, some consciously, some subconsciously, of their surroundings, and therefore it impacts speed selection and the ultimate speeds that they're driving. So this is along that same road. This is on the Alberta side. Within the urban area, there's this concrete portion with a concrete surface as well, and a curb and gutter. But then at a certain point, that changes to a grass median. And although we still have a curb and gutter, because that's the urban sort of more urban treatment, and the treatment that's appropriate for a 60-kilometer-hour speed. If you were to impact, if a vehicle was to impact that curb, they can be deflected back. But the change in the surface helps imply that that you may be starting to get into a slightly different area. And then as you proceed further east and then outside of the city limits, it eventually becomes a depressed grassy median, which to the driver is synonymous with highway high-speed driving. And especially if there is a cable barrier installed, that provides more protection. And it's a wider median as well. So providing a transitional median treatment can be an effective transitional treatment. The fourth and perhaps most effective, I would suggest, and what I think is underutilized in Canada, but very well used in other countries around the world, is what's called a gateway treatment. So if we look first at the image to the right, this is sort of a depiction of what's typical in the country of New Zealand at the entry to a town. There is a slight perhaps narrowing or shift in the alignment of the lanes, with a bit of a median in the middle. Very prominent speed limit posted, as well as the reason, which is that you're entering this city. And then other vertical treatments such as street lighting, trees that help provide sort of a tunnel, again a bit more of like a gateway effect. And the whole idea of a gateway is to communicate to the driver that you need to pay attention because you're entering a different area now. There's something different going on up ahead, and you may expect more conflicts, pedestrians, accesses, and higher speeds are no longer acceptable. At the Saskatchewan intersection, on the left, this is what we suggested, was a gateway treatment with an overhead treatment. Overhead can be even more effective in terms of conveying that you're in a different area. As I mentioned, on the way out of the city, that overhead railway overpass was already acting as a gateway treatment. So what we did on the way out is we recommended the speed limits be put right on that, so just sort of compensate for just at the moment where drivers tend to increase their speed, is to emphasize that this is actually the speed limit here. It's the transitional speed limit, and there's a few reasons why you still need to pay attention, like these other access points that are coming up. So that's gateway treatments. And then the fifth, it says 4, but that should be treatment number 5, especially where you have a high speed variance and you've put in a lower speed limit, is to provide speed feedback. Because again, people are reacting more to cues of the land use, perhaps more than the speed limit itself, and they're therefore less able to manage their speeds. But if they know what speed they're going, they're in a greater position to manage those speeds and slow down to the speed that they need to. And went backwards. Okay, and then the last one is workload reduction. So I spoke before about how all of these signs at jurisdictional boundaries and even at urban and rural transitions could perhaps take away from other important signs, as well as act as a bit of a distraction, especially if they do have many lines to read, like some of these do. And arguably, if safety is the number one consideration in a Vision Zero or safe system context, then some of these other signs, which are important for other reasons, may be foregone in order to keep safety paramount. And in many cases, these signs could be moved further downstream, perhaps away from a key conflict point like the intersection in this case. So I'm going to leave it at that, but if I guess there'll be questions at the end of the session, so I'll stick around. And thank you again for being here. I hope you're having a good time at the conference, and I'm looking forward to continuing to tune in virtually. Thanks, everyone.
Great. Thank you very much, Raheem. We are now going to be listening to a recorded session. And the presenter is Rod King. I'll just read his bio for you right now. By the way, the reason why he is virtual is he's over in the United Kingdom. So we're having some authors present to us from quite far away. So Rod King set up an initiative called 20s Plenty for Us in 2007 in order to assist communities wanting lower speed limits, with a focus on setting 20-mile-per-hour limits for most urban village roads across a complete local authority. It is now has over 600 local campaigns in UK, Ireland, USA, Canada, and Australia. 20s Plenty for Us is a not-for-profit organization with a small core team with thousands of local volunteers. 28 million people in the UK live in local national authorities that have or are planning 20 miles per hour as a speed limit in most urban village roads. At a global level, 30 kilometers per hour is recognized as the best practice speed limit for streets shared between motorists and vulnerable road users. So in one last thing here, in June 2013, Rod was awarded an NBE for services to road safety and provides his time on a pro bono basis. He has spoken at transport, active travel, road safety, and public health conferences around the world. So he will be speaking to us on the road to 30 kilometers per hour as a default urban village speed limit.
Good afternoon. I'm delighted to be here speaking to you this afternoon. My name is Rod, and I'm the founder and campaign director for 20s Plenty for Us, or Love 30, as we are called in places which use
I apologize.
Good afternoon. I'm delighted to be here speaking to you this afternoon. My name is Rod King, and I'm the founder and campaign director for 20s Plenty for Us, or Love 30, as we are called in places which use modern units. I would say that I'm really not here to tell you what to do, but hopefully I can give you an idea of what is happening elsewhere, and if that inspires you, great. I guess the other thing is that I've got a lot to get through, so some of my slides are a little bit detailed, but I know they're going to be available to you afterwards, so forgive me if I don't go into all the detail, but hopefully they'll be there for you to reference should you want to do so. If I can, I'd like to throw in a few ideas. How do we share equitably and safely those public spaces between buildings that we call streets? How do speed limits question our values, our rights and justice, which we want in society? And really, is a 50-kilometer speed limit set decades ago appropriate for 21st century community needs? The areas which I'm going to cover is who we are, what's the history of 20s Plenty and the Love 30 movement and its status today? Should 30 kilometers per hour be set as exceptions, or should they become the norm? What are the results which have been found from 30 kilometers per hour as a community-wide default? And how, when implementing 30 kilometers per hour, can you maximize its successes? Well, we help communities and authorities to set 20-mile-an-hour limits, better balance the movement. We assist and empower those who want lower speed limits with evidence, information, and so on. We very much align with global best practice, And that is to set 20 mile an hour or 30 kilometers per hour as a norm where people are. We hope to influence globally as well as locally. And we have around about 600 local campaigns calling for 20 mile an hour or 30 kilometers per hour limits. And that's thousands upon thousands of volunteers who are saying, we want to change behavior on our local streets. Well, a history of UK 20 mile an hour limits before 2006, if I can break it up into, if you like, eras. Before 2006, it was very much based on 85th percentile previous speeds, very much site specific and required justification, mostly with physical calming, a few roads only, therefore expensive and very sparse, successful in terms of reducing speed, but the expense limited the replication. And of course, it endorsed carry on at 30 mile an hour on most of the roads which pedestrians and cyclists were using. A big change came in 2006, where there was a change in guidance which endorsed the use of limits without physical calming, and the 85th percentile was scrapped, and instead it was said, or the guidance was to observe average speeds. And that led to citywide, authority-wide 20 mile an hour in Portsmouth, followed by Oxford, Islington in London, and Warrington, which was the town where I was campaigning for a 20 mile an hour limit. But by 2006, we had around about less than 1 million people who had a 20 mile an hour limit for most roads. There was a change in guidance in 2013, and that really made a big difference. It endorsed 20 mile an hour without physical calming for many roads. It referenced the setting of 20 mile an hour on roads where average speeds were higher than 24 miles an hour. And by 2020, the setting of 20 mile an hour limits was for most of the largest urban authorities, many shire counties, all the inner London boroughs, the capital cities of Edinburgh and Cardiff. Wales is actually planning to set a national urban 20 mile an hour limit by September 23, and Scotland plans to have 20 mile an hour as an urban norm by 2024. In fact, 28 million people have or are planning to get 20 mile an hour on their streets, and there's more coming. And in Europe, yes, cities are very much accepting that 30 kilometers per hour is the norm. In May 2021, Spain set 30 kilometers per hour limit as a national urban default. So it is very much becoming the norm throughout Europe. And often these include major arterial routes. Here's a 6-lane dual carriageway in Bilbao and a 4-lane arterial road in London. Globally, the UN is also endorsing 30 kilometers per hour. First came in 2017 when the Global Road Safety Week features that tagline, save lives, slow down, particularly for vulnerable road users in cities and towns. The Stockholm Declaration in 2020 declared that 30 kilometers per hour should be the speed limit where motors mix with people. And last year's UN Global Road Safety Week, the tagline was Streets for Life, Love 30, right, as a default. And indeed, it's a key feature of the UN second decade of action from 2021 to 2030. And that Stockholm Declaration, the key measure with regard to speed management, was mandating a 30 kilometer per hour limit in areas where vulnerable road users and vehicles mix in a frequent and planned manner, except where strong evidence exists that higher speeds are safe. So 30 kilometers per hour is now very much a global standard for urban streets and villages. Key reasons, well, global road fatalities of 1.4 million is a very good reason for the to adopt 30 kilometers per hour in order to reduce those casualties. It's effective in reducing pollution and also emissions, which is important for the global climate emergency. And of course, there is a global aspiration to just make our places better places to be. So should 30 kilometers per hour be set as an exception or as a norm? Well, let's look at some of those those alternatives. First of all, 50 kilometers per hour everywhere, and in some places slow down to 30 kilometers per hour. Well, it actually endorses 50 kilometers per hour on most streets. It maintains those high emissions from stop-start driving. It requires physical calming because it's not the norm. As soon as you do that, it becomes 30 to 50 times more expensive. So 30 then becomes expensive in cost and resources. It becomes limited. 30 around schools addresses the perceived drive danger for drivers, but actually it doesn't address the danger to pupils. You have a go faster sign just past the school. It gives priority to those driven into a school zone, and it leaves 50 kilometers per hour for the largest part of a pupil journey. It really does maintain the hegemony of motor car and prioritization of motor cars. Set 30 kilometers per hour as a norm, and you have something different. The consensus becomes we travel 30 kilometers per hour everywhere in our city and village streets, but we go faster only where safe. It endorses a new norm on sharing space with pedestrians and cyclists. Opportunity for wide engagement assisting that behavior change. It's far more cost effective. Okay, the reduction which you get is lower, but there's a far wider effect. For the same cost, you can treat 250 people on a street or 12,500 people in a community. You get wide benefits which are maximized across the road network. Less road danger, fewer emissions, less noise, greater priority to active and sustainable travel, increasing mobility equality, and ending the hegemony of the motor car and that prioritization. It becomes a foundation for so many active travel initiatives. And here's a slide which perhaps goes through some of those arguments in more detail. 30 kilometers per hour limits, they're not a silver bullet for climate change reduction or anything else, but they are the single most cost-effective intervention that provides a foundation for transport carbon reduction, active travel, movement equality, livability in communities, and public health. And if a 30 kilometers per hour limit as an urban norm is considered too difficult for your place, then we think you're unlikely to achieve any of your climate change ambitions. It really is something which is foundational and for getting that change in the way in which we use streets and choose our mobility options. Key takeaways from Europe's adoption of 30 kilometers per hour as a norm. Well, wide benefits go well beyond casualty reduction. Active travel, public health, climate change, placemaking, casualty reduction, strong public support, and it's very much value-based. Progressive cities are the first adopters. They understand the benefits, and we've seen this with London, Paris, Brussels, all going forward. But then it expands into other counties and rural mixtures of towns and villages. Should it be done nationally or by local authority? Well, the top-down approach has been taken by Spain and Wales, and it enables complete countries to leapfrog from local implementations to national. And it very much normalizes 30 kilometers per hour in the presence of people with little physical calming, lots of engagement, enforcement. We'll look at some of those examples which we've got from the Scottish borders, and most importantly, it delivers it for everyone. Scottish Borders Council at the back end of 2020 set up a 30 kilometers or 20 mile an hour as a limit on all of their roads across 97 towns and villages. They did extensive monitoring of before and after speeds. And this graph shows the before speed, average speed there on the x-axis, and the y-axis shows the reduction which there was in speed. Now I've put on a couple of the 40 kilometers per hour and 50 kilometers per hour markers here. But we can see that at 40 kilometers per hour, there was a 5-kilometer reduction in speed. And at 50 kilometers per hour, there was a 9 kilometers per hour reduction in speed. Okay, it's not compliance, but this represents a huge benefit, right, in terms of reducing those speeds. In fact, the reduction was so much that this graph shows the number of sites and their mean speed beforehand and afterwards. And the dotted line shows the enforcement threshold for 20 mile an hour limits. And it can be seen that the green columns there shows that across the whole network, the average speeds were less than the enforcement threshold. And again, if we look at the ratios of fatality to total casualties, right, in 20 mile an hour limits and compare those with 30 miles an hour, right, then you can see on here that likelihood of death in a 20 mile an hour limit is much lower for all classes of vehicle, right, or road user, right, than it is in a 30 miles per hour limit. Casualty reductions in practice. Well, UK authorities were finding 20 to 40% reduction in casualties. And if we look at the EU, some of the experience there, Spain across the whole country, when implemented, a 14% reduction in fatalities, Brussels 19% reduction, Bilbao 24% fewer crashes, Helsinki actually recorded 0 fatalities on their roads, and Oslo 0 pedestrian or cyclist fatalities. So we know that 20 mile an hour and 30 kilometers per hour work. They bring down casualties wherever they're implemented. On emissions, the physics says it all. The actual energy required to take a vehicle up to 50 kilometers per hour is nearly 3 times higher than getting up to 30 kilometers per hour. And that's why in our crowded networks that we're constantly reducing speed and accelerating back up to the limit, then a 30 kilometers per hour limit is going to reduce emissions compared to 50 kilometers per hour. In fact, again, the results show Imperial College report an 8% reduction in NOx and PM10, incidentally equivalent to removing half of all petrol cars from the roads. Berlin 2021, nitrogen dioxide levels dropped by up to 3.8 micrograms per cubic meter of air, significantly less stop and go traffic. Future transport modeling in the UK modeled a 25% reduction in CO2 and NOx, plus all the benefits and reductions which come from modal shift by making safer and more attractive cycling and walking, that first and last mile for public transport, and also catalyzing the city into designing for people rather than cars. How can you maximize success? Well, the big mistake is to think this is about traffic engineering. It's much more about social engineering and changing that public consensus. It's about marketing, engagement on the societal benefits. So everyone sees by changing their behavior, they get a better city, right, and village. It's put into the context of those huge community and societal benefits, providing value-based benefits to compliers. And again, do so by creating a multi-agency collaborative team from different sectors of society, whether that be traffic, engineering, it's public health, it's education, it's emergency services, a complete team of people bringing this transformational change about. Involve and be inclusive of all sectors, even if they oppose, right? bust a myth, challenge opposing views, quantify issues, and turn all of those into benefits. And create the social norm that people love 30, where they live, learn, work, and shop. And it makes it all a better place for all of us. And how can road safety professionals really maximize the benefits of all? And I say this particularly for road safety professionals. Recognize that the 50 kilometers per hour default is no longer fit for purpose. It's not protecting people in the way we want them protected in this 21st century. Road safety professionals should treat 30 kilometers per hour limits as an opportunity rather than a threat. Build on that strong support, right, for 30 kilometers per hour and 20-mile-an-hour limits. Successive surveys in the UK have shown that 67%, 70% of people support 20 mile an hour as the right speed limit for residential and high street roads. Work with public health and other services in multi-agency teams on population-wide implementations, and embrace new methods such as intelligent speed assistance, automated enforcement, and community speed limit. And most of all, recognize that this is a global phenomenon. The world really is changing, and recognizing that 30 kilometers per hour creates streets for health, streets for the climate, streets for people. And by all acting together, we can actually get the best benefits for all communities, all cities and villages, if we really say that if we want our streets for life, we should love 30. Thank you for your attention. If you love 30, where your people play, shop, learn, and live, then you can make your place a better place to be. And please contact me if we can help in any way or provide the information or assistance you need. Thank you for your time and attention once again.
All right, I wanted to thank our three presenters. We do have time for some questions. So obviously not Rod King, whose his was a recording, but Raheem's still here and Abdul. So does anybody have any questions for either Raheem or Abdul on their presentation? We have somebody in the back there. Could you go to a microphone, please? I don't think that they'll be able to hear you though.
Thanks for both presentations. My first question's for Abdul. So I might have missed it, but in your methodology, when you were looking at post-encroachment time, how did you measure those conflicts? So is it like based off video analysis, or where did that data come from?
Why don't you come up here?
Okay, so the data I had was collected in the US, and it was based on video data. I did not myself calculate the PET, but it was based on video data, and it was calibrated in several steps. I looked into the calibration, and it's quite extensive, but overall it was cut off at a 5-second threshold. So anything below 5 seconds was considered a conflict.
And then in addition to that, you looked at protected left turns. Why did you not look at leading pedestrian intervals if you were interested in pedestrian collisions?
I'm sorry, can you repeat the last portion?
So you looked at protected left turns, right? Did you consider leading pedestrian intervals at signalized intersections?
Yes, actually, there was a study published recently that looked at that indicator, but for my my methodology, I was mainly focused on the the reduced speed limit and only partially focused on the protected left turns, just because the protected left turns were actually if you consider all the locations I looked into, only relevant in 2 locations, because most of the other locations did not even have the potential to add a protected left turn at the minor roads. But that's basically the reason why. It's because the focus was to only consider what was available at the locations that I looked into. And so protected left turns were just one of the countermeasures that could be addressing the pedestrians. Yeah.
And then I had a quick question for Rahim as well. I didn't know if there was any evaluation of the treatments that you mentioned, specifically the transitional markings.
Sure. I mean, this particular project was quite recent, so I think they're still looking at the recommendations. But in terms of more generally, I don't recall specifically what sort of the collision modification factors are associated with the optical speed bars. So I'm sorry, I don't have an answer for you on that. Where you can get a lot of this good information is from what's called the CMF Clearinghouse, which is an online resource available from the Federal Highway Administration. So if you were to just Google CMF Clearinghouse, that's where you can find reduction factors for a lot of these treatments. And I think the optical speed bars are in there.
Thanks.
Any further questions?
I had one question, if you'll permit me, for Abdul. Abdul, you had kind of outlined the forecast what the safety performance would be based on different reductions of the speed limit. I was wondering, was there an underlying assumption there then that vehicles would go that speed limit? So
yeah, actually, that was the main thing I looked at, because obviously people will not just follow the speed limit, and that's where I looked at the research before me. So there were multiple studies that looked at how posted speed limits actually affect operating speeds. So there is a correlation, but it's not just a blind follow of the speed limits. There was, however, a reliable approach to estimate how the reduction in posted speed limits would reflect a reduction in operating speeds. So it was one of the key factors that would affect operating speeds, not the only sole factor.
Great, thank you.
Any further questions?
A question for Rahim. Mark Wilson, I just question you. You brought up the gateways, and you made the comment that we should use them more here in North America. And I've certainly experienced them in Europe as well, and they're very effective. Is there any further discussion around that and the wider use of gateway treatments on that urban rural transition?
That's a good question. There are some guidelines that have been developed by the Federal Highway Administration. That was several years ago. I believe gateway treatments were recognized in some of the major Canadian studies, including TAC's Speed Management Guide, and in Alberta's Methods of Reducing Collisions on Alberta Roads. In fact, those guidelines actually developed for their use, and I think they're all ready to implement some of them, and then the economy tanked, so that didn't happen at that time. Maybe it has now. So yes, there are some sources available, and if you were to email me directly, I could send you the links to those.
Great, thanks.
Sure.
All right, well, I wanted to thank the presenters again. In lieu of a gift, we are giving a donation to the Cars Youth Road Safety Committee. And so again, thank you to the presenters. We have our lunch now, and our session in the afternoon starts at 1:15. Talk to you later.